Then we move on to pre-features for modeling. So we do from sklearn pre-processing import standard scalar, and these are what we're doing here is basically we're preparing features for modeling. So features to keep is equal to age, tenure, usage frequency, all the way up to last interaction. Basically, what this line of code does is basically creates like a list starting like the original numerical features from the data set. Next, we move on to feature to key plus or equal to brackets f plus encoded for f in categorical features. Well, basically what this does is basically it uses list comprehension to basically add encoded version of all the categorical features to the feature list. Next, we move on to features to keep, which is plus or equal to tenure ages ratio all the way up to usage per month. Basically, what this does is it basically adds like the previously created engineered features to the feature list. Then we move on to features to keep plus or equal to f plus log for f in features to transform. Basically, what this line of code does is it uses like list comprehension to add all the log transform features to like the feature list. Then we move on to x train is equal to train processed brackets features to keep all the way to y train is equal to test processed brackets churn. Basically, this block of code extracts only the selected features from the processed data sets, and then it basically creates like a separate variable for the x and like the y target, and does like both, and does this both for like the training and testing data set. Next, we move on to scalar is equal to standard scalar, x train is equal to scalar dot fit transform x train, x test scaled is equal to scale dot transform x test. Basically, what this block of code does, it basically creates like a standard scalar instant, and then it fits the scalar to the training data, and then transforms it by standardizing the feature to like the zero, mean, and like the unit variance, and basically applies the same scaling with the testing data without fitting to prevent like data leakage. Then afterwards, we print out a final feature set is equal to length of the features to key features. So the final features are like now like 21 features. Then we move on to model training, prediction, and evaluation. So from sklearn, the linear model, we import in a logistic regression. From sklearn assemble, import random forest classifier. Then we do from sklearn metrics, we import accuracy score, precision score, recall score, F1 score, and the classification report. So first we train like the logistic model by saying RL is equal to logistic regression with these parameters, and then we fit it with like x trained scaled and then y trained. Then we do y predict RL is equal to RL predict x trained scaled, and then we do RL predict prob LL is equal to LL predict prob x test scaled. Basically, these line of code is we use to basically make predictions with logistic regression. Then we move on to training with random forest models. So RF is equal to random forest classifiers with these parameters. RF.fit x train scaled and y train. Then we move on to y predict RF is equal to RF predict x text scaled. Then we do y predict prob RF is equal to RF predict prob x scaled x text scaled. Basically, these are used to make predictions with the random forest classifier. Then we move on to evaluating the metrics for both the logistic regression and the random forest by basically printing out their accuracy, their precision, recall, and F1 for the for logistic regression, and that's done for the same for the random forest classifier. Then we move on to the classification report, printing out the classification report for the logistic regression and then the random forest. So here's our model evaluation. The logistic regression results, the accuracy is like about 56, precision is 52, recall is 99, F1 score is like 68. Then we have like random forest classifier, which is their accuracy like 50, precision is like 48, recall is 99, and F1 score is like 65%. And then we have the classification report for the logistic regressions for like non-churned and then churned. For the logistic regression for precision, recall, F1 score, and support. And we have the same classification report for the random forest classifier for non-churned and then churned for precision, recall, F1 score, and support. So basically from this data, we can tell that logistic regression, like especially for class 0, has like a very high precision score, but with a very low recall score as compared to when it's churned, it has a very moderate, like 52 precision, but with a very high recall score. Basically, this model catches like almost all the churnels, but not all. Then for the random forest classifier for class 0, which is like non-churn, it has a very high precision score with a 98%, but with a very low recall score with like a 6%. And then we have for class 1, which is like churn, it has a very low precision score of like 49%, but with a very high recall score of like 1%. Basically, both of these models are like highly biased towards like predicting like churn, but like overall the logistic regression performs slightly overall better in like when it compares to like higher accuracy, higher precision, and then a better like a recall score. So yeah. So this was the entire project for the customer churn prediction dataset. Thank you for watching.